let's do that part.
Perceptual transference and pain.
All right, if I can get there.
You can do it.
Okay. Caroline and I were just talking about immune dysfunction and how important the function of histamine is in how the body physiology changes and goes through the process of what we call aging. Histamine is a neurotransmitter, and it has both immune functions as well as functions in the nervous system, and that is not yet taken into account in our understanding of disease. Histamine, as it is secreted as the body is penetrated, is part of the inflammatory cascade, and it calls in white blood cells to eat these protein complexes that are getting in. But if they keep getting in, histamine also goes up the blood vessels as these molecules enter the body through the mesentery, which is the septum that hangs down from the spine that the intestine is nourished by. And all of the blood from the intestine goes first to the liver, where these poisons are processed and these antibodies are processed. When the liver is overwhelmed with immune dysfunction complexes, these complexes get out into the general circulation and produce microemboli. And this is normal physiology, and it is not yet understood that way. Every day we make immune complexes, depending on what we've eaten and how our bowel flora is cooking. And these immune complexes, if they accumulate into clumps, form clots that become embolic. Most of the time this is reversible. And if we're underhydrated or we have other factors, as in Virchow's triad of what predisposes people to coagulation, it sets the stage for what we call disease in the vascular system and the inflammatory system. Now, as histamine enters the body, it first stimulates the adrenals, and it tells the adrenals, we're being penetrated. That stimulates the adrenals to put out adrenaline and noradrenaline, which are the alerting neurotransmitters and the ones that tell it to move around and figure out how to either get away or figure out this stressor. But it also makes it put out cortisol because it tells the body we're being penetrated and we're going to need sugar for the white cells. So the histamine's effect on your insides is that it raises cortisol, and that raises blood sugar and mobilizes glycogen stores. The pancreas, which has to put out insulin to cope with the high sugar, also puts out digestive enzymes at the same time. Now, why would digestive enzymes be part of this? Well, digestive enzymes break down the antigens in the food better, which lowers their antigenicity, which lowers the antigen load as the food gets down to the terminal ileum where the histamine's going on. So if the molecules are no longer antigenic, they will not evoke antibodies. And so this is the feedback loop of how penetration in histamine tells the body how to regulate secretion of digestive enzymes. One day, one of my patients, who is a veterinarian who used to teach up at the University of California Veterinary School at Davis, came in, and we have some very interesting conversations about medicine. And she asked me, do humans age like cats and dogs through pancreatic insufficiency? Well, I said, humans get pancreatic insufficiency, but nobody ever asked me that. But I thought about it, and it makes some sense. But see, if you understand the stress physiology of immune dysfunction, it would gradually lead to pancreatic insufficiency as the gland wore out. So suddenly, my patients who have sworn by digestive enzymes all these years, it suddenly makes more sense that this would be a way to help your body reduce this histamine drive and reduce this immune dysfunction. People want to know what